Assalamualaikum and greetings everyone. Okay, let's continue with example of sketching graph of a vector function. Okay, let's solve or sketch example 1. In example 1, we have a vector function rt equals ti plus t squared j. As you can see here, we only have two components, x and y, but we don't have the z components, meaning that our curve is going to be on a xy plane instead of xyz space. So we're going to start with a curve on a plane first before we proceed to a curve in xyz space. Alright, so here we have the vector valued function rt is ti plus t squared j. So from there, we can extract the parametric equations for x and y. So this is the x component. Okay, so the parametric equation for x is going to be equal to, so x is going to be equal to t, and the parametric equation for y is t squared. So for y, we have t squared. Okay, so now we're going to get a few points and also a few position vectors for different values of t. Okay, let's say we pick a few negative 0 and positive t. Okay, let's see what happened when t is negative 2. When t is negative 2, we plug it in our vector valued function r. Then the x component would become negative 2. And for the y component is negative 2 squared, which is a 4. So then we have 1 point, which is negative 2, 4. So negative 2, 4 would be the point at the endpoints endpoints of our position vectors. So now the position vectors, second column, the last column, for t equals negative 2, we have negative 2i plus 4j. So that's the position vector when t is negative 2. And let's say we pick t is negative 1. Then for the x component, we have negative 1. For y, we have positive 1. So we have another point, negative 1, 1. And we have another position vector when t is negative 1, which is negative I plus 1j. Okay, now let's see what happened when we replace t with a 0. When t is 0, we get x is 0 and y is also 0. So we have a point at the origin. So the position vector when t is 0 is 0i, 0j, or you can write it as 0 vector. 0 vector is really 0i, 0j, or you can use the pointy bracket. So if all the components are 0, we just write the vector as a 0 vector, which is 0, and then you put a tilde sign underneath. That means 0 is a vector. Or if you type your answer, then 0 should be in bold letter to represent a vector instead of a value 0. Okay, now let's get a positive t. When t is 1, x is 1, y is also 1, so we have another point 1, 1. Or the position vector when t is 1, we have 1i plus 1j. Okay, now let's see what happened when t is 2. When t is 2, x is 2, y is 4. So we have another point 2, 4, and another position vector, which is 2i plus 4j. Okay, now we're gonna sketch the position vectors. Remember, to plot a curve in space, you need position vectors, which are this, all right? And then you connect all the endpoints of the position vectors to get the curve for vector valued function. All right, so x, y here are the endpoints of our position vectors. Okay, so remember, position vector starts from the origin. So for negative 2, when t is negative 2, we move from the origin here to I, meaning we move 2 units to the left. So let's say this is 1 unit, this is 2 unit. Okay, and then from there you move 4 units up. So we have 1, 2, 3, 4. Oops, this one is a 4. Okay, so we have a point that is a point 2, 4, and then you just draw a straight line. Remember, position vector is a vector that starts from the origin. So from the origin we have one vector there. So this is a position vector when t is -1. Okay, now let's look at another position vector when t is -1. Oh, did I say -1? No, that one is -2, sorry. Okay, now let's look at the position vector when t is -1. So again, we start from the origin, okay, and then we have -I, meaning you move 1 unit to the left, okay, and then 1 unit up, okay, so this is 1, right, and then you draw a vector, a straight line from the origin, because it's going to be a vector. Okay, so here we have another position vector when t is -1, right? Okay, so this is position vector when t is -2. This is position vector when t is -1. Alright, when t is 0, we start from the origin and then it doesn't move anywhere because at t0 we have a 0 vector, so it just stay at the origin. And then when t is 1, we have 1i plus 1j. So from the origin here, you move 1 unit to the right and then 1 unit up here, okay, and then you just draw a vector from the origin. So that would be a position vector when t is 1. And the last one is for t equals 2. So when t is 2, you start from the origin, we have 2i. So for 2i, you move 2 units to the right, and then you move 4 units up. So we have 1, 2, 3, 4, okay, and then you draw the a vector from the origin. So that would be our another position vector when t is 2. So this is position vector when t is 2. Okay, so remember before, next is we need to connect all the endpoints of the position vectors to get our curve in space, which is represented by the vector function r. Okay, so going back here, so we have a curve. All right, I'm going to use some green. Oops. Oh dear, what happened? Okay, now we're going to connect all the endpoints of the position vectors. So what we have is this curve goes to 0 and goes up, and then we have that. Okay, so the green is our vector function r. Okay, a vector valued function r. All the black vectors are position vectors. Okay, let me put that here. So these are all position vectors. Okay, position vectors. And the green curve, green curve is the vector function r. All right. As you can see, for a vector, remember for a vector, it has magnitude and direction. See here, I'm using the direction where we move from the left to right. So to determine the direction of your vector, you look at how the parameter t increases. Okay, you look at how the parameter t increases. Okay, so here, at this point, this is when t is -2. And then this point here is when t is -1, and this is when t is 0, t1, and t2. So the value of t increases as you move from left to right. Hence, the direction of your vector is from left to right. Okay, so that's how you determine the direction of your vector function rt. I'm going to erase that. Okay, so what you do is you look at how the value of t increases. So in this case, the value of t increases from left to right. Hence, the direction is from left to right for vector valued function r. Okay, so that is one example. Right, how are we doing with time? Okay, I'm going to save the next example in our next video. Thank you.